Good morning, sir. My name is B. Ramu. I'm from third year ECE B section from Institute of Aeronautical Engineering College. So today I'm gonna give a presentation in the subject of computer architecture. So my presentation topic is big LOT data analytics and architecture opportunities and open research challenges. So let us talk about introduction to big IoT data analytics. So we can see the picture. I'm here representing with a pictorial representation. So if we can see the picture, we can easily understand how the big IoT data analytics can be done. We can see IoT analytics platform types. There are many types of online platforms are there. Like there are 7 types of platforms. First one, descriptive analytics, and second one, diagnostic analytics, predictive analytics, perspective analytics, real-time analytics, edge analytics, cognitive analysis. So coming to brief introduction about big IoT. The internet IoT stands for Internet of Things. It generates massive volume of data from various devices. Basically, it's gather the information from various devices. Uh, the data in various forms. There is no particular form of data. So analyzing this data can provide valuable insights for industries, enhancing decision making process. So mainly it can be used in industries as well as decision making process. Big IoT data analytics refers to the techniques and tools used to process and derive insights from this data. So there are key components of IoT architecture. So again, the IoT stands for Internet of Things. Sorry. Architecture typically consists of devices, communication protocols, data processing, and user interfaces. This device collects the data and communicate through the various protocols such as MQTT and HTTP. So there are these are like channels, transmit the data and receive the data. A robust architecture is essential for efficient data flow and real-time analytics. We can see the picture. So what are the key components when we use IoT architecture? So the architecture consists of different layers. For example, 3 layer, 4 layer, 5 layer, and 7 layer. So you can see the picture. In 3 layers, there are first layer is prescription layer, and second one network layer, application layer. Coming to 4 layer architecture, uh, it consists of 4 layers. uh, Devices or the prescription layer, internet gateways, edge computing, cloud or data center. And coming to 5 layers architecture, prescription layer, transport layer, processing layer, application layer, business layer. And coming to 7 layers architecture, first layer is prescription layer, connectivity layer, edge computing layer, processing layer, application layer, business layer, and the last one is security layer. So in every layer, prescription layer is mandatory. So we already told that it basically collect the data. So how the data will be collected and what are the techniques we are used in IoT architecture. Let us talk about briefly. Data from IoT devices can be collected through sensors, actuators, and gateways. Techniques such as edge computing help in processing data close to the source and reducing latency. Here, latency means picture clarity or else data clear information, like efficient data collection methods ensures high quality data from analytics. If you want quality data analytics, we compulsory use efficient data collection, then only you get the high quality data. So we can see the picture how the data will be connected. So there are different devices, uh, you can see devices and any connectivity. There are router, Wi-Fi, antenna, or tower. So these are connectivity devices. So using that, every connectivity devices, there are different channels. You can say that REST API and MQTT, CoAP and custom. So we already talk about cloud. So it consists of internal processing. So there are rules engine and storage and etc etc. So the output of the cloud we can use in real time application, like a data push and a data pull. And it means we push the data or else we pull the data based on our requirement. So this is a overall process how the data will be collected, and how we can use in real time applications. So how the data will be stored and what are the solutions in IoT architecture. So big IoT data requires scalable storage solutions to handle large volume of data. So to store the large volume of data, it requires scalable storage. It means it already decided how much storage will be required. That much of is enough to store large volume of data. So it varies based on data size respectively. Cloud storage, NoSQL database, and distributed file systems are commonly used for this purpose. The choice of storage solution impacts the speed and efficiency of data retrieval and analysis. So if you want efficiency data or else efficiency data retrieval and analysis, these two things are based on uh, which storage solution you chosen. Based on that, these both are will work. So here we can see some solutions method. First one is fog cloud interface and second one is fog things interface. So there are what is cloud and what it consists, and what is fog, and how the internal structure will be there, and what are the devices and what are the connectivity devices is there, and how the interface will be happen. Total information is there in the picture. And sensing and collection elements, indexing, query and discovery, data processing and frameworks. In IoT architecture there are different different stages are there. So these the combination of these all stages, we can call it as a framework. Various frameworks are there in the IoT architecture. So like Apache Hadoop and Apache Spark and are utilized for processing IoT data. So basically there are two types. Here I'm telling for example. One is Apache Hadoop and another one is Apache Spark. So these are two used in processing IoT data. These frameworks enable batch processing and real-time analytics catering to different use cases. Selecting the right processing framework is crucial for optimizing performance and resources utilization. So here I am shown one tree diagram. So how the framework will be happen and what are the internal stages is there in the framework, and different stages we can call it as different names like data processing, data storage, message broker, and end user. Like you can see the picture, you can easily understand how the framework will be happen. Opportunities in big IoT data analytics. Enhanced predictive analytics allows business to forecast trends and make proactive decisions. Improved operational efficiency can be achieved through real-time monitoring and data-driven insights. New business models can emerge driven by data monetization and improved customer engagement. So there are different types of analytics are there. I already told that descriptive analytics, diagnostic analytics, and the predictive analysis, prescriptive analytics. Not only this, there are different types, but I am shown here to get idea of that. Uh, I already told that this IoT architecture basically use into two places. One is industrial and second one is decision making process. So how the uh, IoT architecture will be used in industries, let us discuss about that. Small cities utilizes IoT data for traffic management and energy consumption optimization. Second one is healthcare applications. Leverage IoT analytics for remote patient monitoring and personalized care. Uh, Here we are, by name itself it suggests that remote patient monitoring. So how the remote will be knows that patient condition based on IoT. These are like works based on IoT. In manufacturing, IoT data analytics enhance supply chain management and predictive maintenance. Open research challenges. I'm Before discussing this, let us talk about this picture. What are the challenges of data privacy? Uh, I'm showing here 6 challenges. Vulnerabilities in web application, insiders and poorly trained employees, lacking breach response, inadequate personal data disposal, lack of transparency in privacy policies, terms and agreements, personal data sharing. So these are like challenges for data privacy. So privacy and security concerns remain significant challenges in handling IoT data. So IoT is also used for data privacy, interoperability, and among different IoT devices and platform is essential for seamless data integration. Developing efficient algorithm for processing and analyzing real-time data is an ongoing research area. So there are future trends in IoT data analytics, and what are those we are discussing. So now I'm discuss about that. The integration of AI, artificial intelligence, and ML, machine learning, AML, will enhance data analysis capabilities. It will enhance the capability of data. So there are increase the capability means there are more number of applications is happen. Edge computing will likely become more permanent, enabling faster data processing and a reduced bandwidth usage. The growth of 5G technology will facilitate more reliable and faster IoT data communication. This picture shows that AI ML trends. I conclude that big IoT data analytics is a rapidly evolving field with significant implications for various sectors, uh, like industrial, healthcare, decision making process, and etc. Stakeholders must invest in research and development to tackle existing challenges and explore new opportunities. Collaboration among academia, industry, and government can drive innovation and establish best practices in IoT analytics. Thank you.